Welcome everyone to the second tutorial on PXE. I'm about a year a bit late, but I guess better late than never. So in this tutorial I assume that you have seen my previous tutorial and I had to recreate the environment because I lost the environment of that tutorial, but I'm going to continue assuming you have followed those steps already. So this tutorial we will set up both HTTP and NFS for booting live distributions, and for the examples we'll be using Ubuntu and Gparted. I will begin with Gparted that uses HTTP, and then I will do Ubuntu that requires NFS and has a little bit more setting up to do. So you can skip to whichever part you're more interested in. So let's begin. We SSH into our server, and I'm going to make the letters big. So once we are SSH'd in, the first step that we want to do is install a lightweight HTTP server. In this case, you can use Nginx or you can use any HTTP server that you want, but for the tutorial's purposes, I'm going to use LightTTPD because it's a very lightweight HTTP server. So as always, you can install it like this and it will download the package. And for this, the configuration is very easy. We simply go to, we edit, etc, lighttpd, and then lighttpd.conf. We're not going to use any special modules or anything easy. So following from the last tutorial, we're going to change this root folder to point to our tftp boot folder. So if you remember, or how it was done in the previous tutorial, the tftp boot folder was the one that had all of the files for the PXE server and is where the tftp server is also pointing at. So I need to point out that the port is going to be running at port 80, and you should leave this alone, but you need to remember to open that port in the firewall. So if you're using UEFI like me, sudo UEFI allow 80. I already have it done, but I redid it. Now that this is done, you can go back to tftp boot. And you can add another entry for HTTP in your default file. So, sorry about that. So this file, I have done it already, but just so you can see, instead of, since the document root is already tftp boot, we don't need to actually do like /tftp boot, but rather /debian, which is where our Debian files are, and just the same files as we are using for the tftp normal booting. So now I'm going to download and copy Gparted, or Gparted live in this case. So let me just fetch a link quickly. So let's get the file. I have the wget thing here, so it should download it as this name, I think. Permission denied, oops. Now, this has been downloaded, so as always, we will mount the image into MNT and then copy it into a folder. So let's create the folder first. I will call it Gparted, and I will mount the image into MNT. I didn't autocomplete this, my bad. Okay, so now we will copy all the contents as always. And in this case, I will do like this instead of with a star like the other time, because then it will also copy any hidden files that are in /mnt. So copy this into Gparted. Now we wait. That was quick. So if we ls into Gparted, we see that we have these files. And this should really be it. It's a very lightweight system. So let's edit our default file. Okay, when booting kernels and booting live images fully from the net, you need to add specific kernel parameters that tell the kernel what to do, aka pulling the rest of the files or rest of the file system over HTTP. So let's start making a label. Let's see. Oh, my bad. Okay, and then the menu label. So then, in the kernel, we are able to pull it also from, using HTTP. Keep in mind that the HTTP service has not been restarted, so we may need to do that later. So as always, with the IP address of my Raspberry Pi. And then the file in which the kernel is for Gparted would be Gparted folder that we just extracted. And inside this, it's inside the live and the VM Linux. Like that. And then to this, we're going to append more information. In this case, the initrd is found in the server again. Gparted live folder, and it's called initrd.img.image. And now these are the parameters that we need to append to the booting line for it to be able to boot over the network the entire live image. So we do boot equals live config components union equals overlay. Username is user, and then no swap, no eject, VGA equals 788, this is just resolution, and then the important part, fetch HTTP, okay, let's go through this a bit. So these options are just parameters that the kernel will take in order for it to know how to boot. So it will fetch, PXE will fetch these two files as always, but in this case through HTTP, and then it will read these parameters. So I'm not exactly 100% sure what all of these do, but you can guess by, for example, username equals the user. You can tell that the username is going to be user when the system boots. You can tell that no swap instructs it to not create a swap, or it does the live session will not have swap. And boot equals live instructs it to boot in a live environment. But these are just guesses. Now, you might be thinking, where have I gotten this line from? So this information, I actually got it from Gparted's own website. As you can see here, these are the parameters that you need for the kernel for Gparted to boot properly. And again, they state if the version is this. My point is that this information you can find online, and depending on the distribution that you want to boot live, you will need different parameters, as you will see later on when we try with Ubuntu. It's different parameters that it uses to boot over the network. So let's save this. I'm gonna try to make sure that I haven't made any mistakes, because any spelling mistakes will make this not boot, but we will see soon. And now, before anything, I will be sure to restart the LATTPD service to ensure that it is running and that it has no problems, of course. Didn't complain, so I assume it is working. So now I'm gonna pop up a virtual machine as always and give it a shot. This virtual machine is instructed to boot over PXE. So it is booting. So far, so good. And here's the Debian but with HTTP, the entry that I already had, and here's Gparted live. So as you can see, it pulled both the VM Linux and the initrd image over HTTP. And now it is getting an IP address on the interface, and it is fetching the file system over HTTP as well. And soon enough, we will see some, we can select the key map. I'll pick US American. And then I'll pick the language UK English. And 0 to boot graphically. And if everything went correctly, I should be prompted with Gparted live. Yes. So as you can tell, this, oh, the mouse is a bit wonky, but as you can tell, this distribution is extremely usable if you do it live over the internet, because if your computer breaks or you don't want to have a USB stick with Gparted everywhere you go, then you can have this alternative and boot Gparted anytime that you need it. So let's keep going with other operating systems. Let's go with Ubuntu. So for Ubuntu, you're going to need NFS installed. And in order to do that, let's install it with sudo install NFS kernel server. So we need the NFS server. Okay. So now that this has been installed, we need to do some prior configurations. The first thing will be to edit the NFS kernel server settings overall. So, and you will see why soon enough. etc default NFS kernel server. So in this file, you want to comment this line out and you want to replace it with this. So the same thing, but instead lowercase p and a random port of your choice. I'm going to pick 40,000 because I know that this port is not being used and I can have it open myself. So why do we do this? By default, NFS will bind a number of different ports for NFS usage, and those ports may not be allowed by your firewall since they may be random. What this does is it ensures that it will use this port that you specified so that you are able to make a rule in the firewall that allows this specific port for NFS to work. And it even says it here that if you have a port-based firewall, you might want to set up a fixed port, the port option. Ta-da! So let's write that. And the first thing is to allow that port in the firewall. So 40,000. But also we need to allow 111 for our PC bind. And we also need to allow 2049. Sorry, 2049, not 40. This one. So if we would see our firewall, then we would have right now for this installation, we would have 111, 2049, 40,000, and we would also have 80 for HTTP. So let's continue. We are going to configure the export file. And in here, we will add the line with first the directory that we want to export. And then I will add to share it with the entire subnet. So these options that we are going to add are actually quite important. No root wash, and then no. So the subtree check is just for convenience to ensure that it doesn't enable it. But then this option is quite important because no root squash will allow root users to mount the NFS share. And this is important because the live environment that it starts booting from is root. And then RO will just instruct it to mount as read-only. So let's write that. And the next thing that we are going to do is to run exportfs-a. And actually I will do AV so you can see what is exporting. Right, so first of all, it failed to export this folder because we actually have not created it yet. So let's actually do that before continuing and restarting any service. So we're in here. I'm going to make the folder for Ubuntu. And ideally you want to download the ISO and move it here, but I already have it downloaded to save time, so it's in my home directory. So I will mount the image and then I will copy it to the Ubuntu folder, which I already have downloaded. So, oh, not that one, to mnt, read only, and if we read mnt, we will see this, great. So let's copy this again. And once more with a dot to copy all the hidden folders, because there is a hidden folder here called .disk that we actually need, into Ubuntu. Now this will take maybe like 25 years.
One eternity later.
Okay, so this has finished copying, and if we see, if it lets us, here are the files. And the interesting folder is the Casper folder. So if we go into it, we can see that we have the initrd and the VM Linux, as well as the entire file system. So let's configure the default file once more to add an entry for this. But before we do that, let's actually run the Gparted and restart the NFS server, because now that the folder exists, it shouldn't complain. So -av, this seems to work, but remember it's only this folder. If you have any more folders that you want to share, you should add them to the list. And then sudo systemctl, bada bing bada boom, no complaints. Okay, so let's now go into the defaults file and add an entry for this. So once more, this entry, you can find it on Google, and the different versions of Ubuntu may require different kernel parameters, but for 2004, this should work. Let's do something like that. And then once more, we can fetch the kernel through HTTP, since we have that set up already. It's in the Ubuntu folder, Ubuntu, as we just saw, and in the Casper folder. And then we do the magic append line. Same with the initrd. We saw that it was just called initrd. And then the important bit is that NFS root is 105, but then colon tftp boot Ubuntu, since this is exactly the same thing that is in our exports file. Then read only, net boot equals NFS, boot equals Casper, and IP equals DHCP. No more parameters. We save this. Make sure that you haven't made any spelling mistakes. Let me make sure about that. Everything should be okay. And we exit. And now with our server restarted and with our HTTP working and with NFS supposedly working, we can check that with rpc info-p to see what ports are running. So mount D is running on port 4000 as we instructed it, 111 for the port mapper and 2049 for NFS. Let's try it with the virtual machine again. So we run the virtual machine. We have the menu here, Ubuntu 2004. It fetches these files with HTTP and then it tries to boot. So getting an IP address now. Trying to mount it, NFS mount, need a path. So something went wrong. it seems to be trying from 1 to 0.1, so maybe I have made a mistake. Let's stop this one. So I am an idiot, and I did make a spelling mistake. It's not NSF root, but NFS root. And it was trying to fetch the root of the NFS from .1, which is my router in reality, but then that's not going to answer. So again, don't be like me and don't make spelling mistakes. Let's try that again. So let's see if it works now. I like leaving my mistakes in because then, well, we all make mistakes. Let's see if it does anything good now. Getting an IP again. This time it did do it correctly, 105. So now it's trying to get all of the files, it's checking. And then this is just a VM, but it could be a laptop connected over Ethernet to your network. Now it's getting the file system, checking it. No errors found. That's good. And now I should fully boot. There is systemd. And here is the system. Mouse. Voila, that's Ubuntu. And I don't have any connected networks, so maybe this works. But there should be a full Ubuntu Live system, just like when you boot from the CD, Firefox and everything else. Anyway, I hope this video was useful and that you learned how to do it. Make sure you don't make any spelling mistakes like I did, and you know, have in mind this has no space in between and all of that. Thank you very much for watching, and I'm sorry it took me so long, but I still hope that this tutorial is useful for everyone trying to do this. Thank you.